Now I will be presenting the mini project for maths, which is ASM 0404. The topic is matrices and this is set C. The situation which we are given is, suppose now Allah wants to send a secret message to Busu in a matrix of dimension 4 times 4 as follows. P equals this entire matrix. Busu now is given three different sets of matrices K1, K2 and K3. The task now is for Busu to decide which the given key will decrypt the message sent by Along and have a meaningful message. In a group of 5 persons, you will help Busu to find the inverse of all three possible correct key K1, K2, K3 as given as follows and decrypt the secret message. The questions are: obtain three different messages from three keys given below. Among those three messages, which messages do you think is correct? Explain. Why do you consider the other messages are incorrect? State your reason. Now we'll find for the secret message using K1. For K1, we'll be using the adjoint method where we'll find for the inverse. By doing so, we will first search for M11, which is the position, row 1, column 1. We will first have to find for the determinant of this, as this is a 4 by 4 matrix. And when it's a 4 by 4, we'll have to find the determinant to get the cofactor. For this, we will delete row 1 and column 1 and we will get the answer 531, 121, 225. Then we will find for its determinant, which will then be the answer for the position M11 in the minor. So, we will apply this method to each position, which is M11, M12, M13 and so on. So now I will explain each of the answer. So M11 is equivalent to 29. M12 is 7, M13 is -1, M14 is 20, M21 is -10, M22 is 2, M23 is 2, M24 is -8, M31 is -67, M32 is -9, M33 is 15, M34 is -44, M41 is 6, M42 is 2, M43 is 2, M44 is 8. These answers all will be put into the minor according to their position. And then, since for minor, we have to change it into cofactor. So here will be positive, negative, positive, negative, negative, positive, negative, positive, positive, negative, positive, negative, negative, positive, negative, positive. We'll multiply each of the values which I told just now to form the cofactor. So we'll get 29, -7, -1, -20, 10, 2, -2, -8, -67, 9, 15, 4, 44, -6, 2, -2, 8. By using the cofactor, we will now find for the determinant, which is 16. Next, for adjoint method, we will first have to find for the adjoint matrix of A, which is in this case the adjoint matrix of C. So, the adjoint matrix of C would be 29, 10, -67, -6, -7, 2, 9, 2, -1, -2, 15, -2, -20, -8, 44, 8. I know you'll be wondering how did we get this. The method is just simple, where we will switch the position of each of it. So for example, -7 we switch with 10. So you'll be getting -7, 10. This is all being switched diagonally. So -67 will switch with -1 and 2 will remain there as there is no numbers for it to switch. So we will get -67 at the top, 2 and -1. Now let's try again for the third diagonal. So you'll be getting, the fourth diagonal. So for the fourth diagonal, we'll be switching -6 with -20, 9 with -2. So as you can see, -20 is switched with -6, -2 is switched with 9. This will apply to the rest of the parts of it. Then, with this, we will get the inverse, which is 1 over the determinant, which is 16, and we'll times it with the adjacent matrix of the cofactor. So, the product will then form the inverse of K1. This inverse is then times with P, and the product we'll get will be the M, which is the message later on. However, as we find the product, we could not decrypt the message as it contains fractions and negative real number. The answers, which is the alphabet, can only be represented by positive integer, and then values must be below 26. As you can see here, it starts from 25 all the way to 0. So 0 is A, 1 is B, and then if you go for 24 is Y, 25 is Z. That is why we aren't able to find for the answer, as we get fractions and negative. Now let's move on to K2. Now we'll be finding for the secret message using K2. For K2, we'll be using the ARO method, where it is known as elementary row operation. In this method, K2 will form the identity matrix, and the identity matrix will form the inverse of K2. So first we'll start by using the method where we replace a row by the sum of itself and a multiple of row 2. So this method will be applied to row 1, row 3 and row 4. Row 2 is the constant, which is the multiple, which we will multiply it with -5, -4 and -2. Thus we will get the new answer for R1, R3 and R4, which is this. Then we will use this previous method and apply it to row 1 to get the new answer, which is 0, 0, 2, 1, 16, -1, 5, 0, 0. And then we will use -1 over 3 and multiply it to row 3, so that we can get the answer 0, 0, 5, 4, 0, 4 over 3, -1 over 3 and 0. Our main goal is to get a matrix where the diagonal is all 1. So this would mean there will be 1 here, here, here and here. However, when we continue this method, we aren't able to get the answer. Since the LHS cannot be transformed into the identity matrix, that means the inverse does not exist for K2. Thus, we aren't able to decrypt the message and get the answer. Thank you.
So first, we want to find the determinant of K3. The first thing we have to do is take out the 3 by 3 matrix. So first we start with row 1 and column 1. This is row 1 and column 1. So we block out the row 1 and column 1, which gives us these elements. So we transfer it out and put it here. Once we take out those elements, we can find the value for this matrix, 3 by 3 matrix. So this is matrix for row 1 and column 1. Row 1, column 1, take out the remaining elements and bring it out here. So for this matrix, we have to multiply it. So this element is taken from column 1, row 1. Then the remaining elements, take it out and put it here. So this element is this element, which is corresponding with the positive value. Next, we have column 1, row 2. Take out the remaining elements and put it here. Now this element is corresponding with the negative value, so it has to be -3. Then column 1 and row 3, remaining values, take it out and put it here. This element is corresponding with the positive value, so here is positive. Once we have all of these values, we just multiply as per usual, and the answer that we get will be 0. So the next matrix that we will be using is row 1 and column 2. So this is row 1, column 2. We block out all the values from row 1 and column 2, and we get the remaining values and transfer it here. So then to find the value of -25, we just have to do as what we did in matrix row 1 and column 1, but now we do it in row 1 and column 2. So block out row 1 and column 1. We have 1, 4, 3, and 2, and the element is 4, positive 4, because it's corresponding with positive value. Then for the second one, row 1, column 2, so we want the value 2, which is corresponding to the negative value, so we put here -2. Then here, the remaining values, we just transfer it here. And then for the last matrix, we just row 1, column 3, which is a positive value, so +3, 1, 2, 1, 1, 2, 3 over here. Then we just multiply as per usual, and we get -25. So for the third 3 by 3 matrix, take it from K3, row 1, column 3, the rest of the values, transfer it here. We get 4, 3, 3, 1, 3, 4, 2, 3, 2. Okay, so row 1, column 1, 3, 4, 3, 2. So we know that 4 is positive. So here is positive value. Then next we have row 1, column 2. Transfer the rest of the values which are not blocked to here. And we know -3 is a negative value. So, put negative here. Lastly, we have row 1, column 3. The rest of the values transferred here, and the corresponding sign is positive, so here is positive. So we multiply as per usual, and we get -15. Then the last one is row 1, column 4. Row 1, column 4. And we get 4, 3, 2, 1, 3, 1, and 2, 3, 3. So we just do block row 1 and column 1. Transfer these values here, and 4 is a positive value. Then next we have row 1, column 2. So for the fourth matrix, we have row 1, column 4. Row 1, column 4. And we get this value. So first is cut off row 1 and column 1. We get 3, 1, 3, 3. And we know 4 is a positive value. Then row 1, column 2. We know 3 is negative, so here is negative. And row 1, column 3. We know 2 is a positive value, so here is positive. Multiply as per usual, and we get -15. So now we can find the determinant of K3, which is here. 3 times 0. Okay, wait. 3 times 0 plus 5 times negative 5 times negative 25 plus 5 times negative 15 and plus 2 times 15. So the answer that we get is 20. So we know the determinant is 20. Next, we want to find the minor. So we have to find the 3 by 3 matrix for all of this. So we need to find all the rows and columns. So now we already found row 1 and column 1, 2, 3, 4. So now we need to find row 2 and column 1, 2, 3, 4. So we start off with row 2 and column 1. So we multiply as per usual and we get negative 8. Don't forget that this is positive, negative, positive. And that's why here is negative and here is also negative. And the answer we get is negative 8. And over here is the same thing. Don't forget the negative sign. Negative, negative. So multiply as per usual, we get negative 25. The same for row 2 and column 3, we get negative 15. For row 2 and for row 2 and column 4, we get 15. And for row, so we go on to the next row, which is row 3. Row 3, column 1, 2, 3, 4. Row 3, column 1, we get the answer is negative 4. Row 3, column 2, negative 9. Row 3, column 3, negative 7. Row 3 and column 4 is negative 1. So for the last row, row 4, we want to find for row 4, column 1, 2, 3, 4. Do the same thing. For row 4, column 1 is 4. Row 4, column 2 is negative 46. Row 4, column 3 is negative 38. And lastly, row 4, column 4 is 26. So the minor, we just sub in all the values that we got from the 4 by 4 matrix. All these values. We just have to transfer all those values into here, and that is the minor. So from the minor, to find the cofactor, we just have to make sure all the values is in the correct form, which is positive, negative, positive, negative, negative, positive, negative, positive, positive, negative, positive, negative, negative, positive, negative, positive. So once we convert all those values, we get the cofactor, which is this value. So if you want to find the adjoint of A, all you have to do is transpose the cofactor. So when you transpose the cofactor, all you have to do is just change the column and the row. For example, here row 1 is 0, 8, negative 4. So this row 1 must change to become column 1. So we do all the same for all the rows and columns, and the transpose of C is 0, 0, 25, negative 15, which used to be row 1 and now is column 1. Then negative 8 to negative 6, negative 2, which was row 2, now column 2, negative 4, 9, negative 7 and 1, which was row 3 and now it's column 3, negative 4, negative 46, 38 and 26, which was row 4 and now column 4. So now we can just sub in into this formula. which is the inverse of which is what we want to find, which is the inverse. And so this is the determinant, 1 over determinant, which is 20, and the adjoint of A, which is this value. Just sub it in and times, multiply as per usual, and we get this answer. So from the table that was given in the PDF, we know that we can compare it with the table, and the message obtained is as per head start.